So welcome everyone to the JUNIPER Consortium's monthly seminar series. So for those of you who don't know me, I am Dr. Kira Dangerfield and I am I'm the Senior Scientific Programme Manager for the Consortium. So if you have any questions, please feel free to get in touch with me afterwards. So first of all, I'd like to say a big thank you to the Isaac Newton Institute, who are virtually hosting our seminar series today. So thank you for all the support that they've been giving us. For those of you who don't know who the JUNIPER Consortium is, it stands for Joint Universities Pandemic and Epidemiological Research Consortium, and it's a consortium of modelling groups from 8 universities who are currently working at the forefront of epidemiology modelling that is informing government advice for the pandemic, and we're funded via the UKRI. So just a quick plug for our research meeting, which is happening on the 7th and 8th of December. So more details of that will follow in the next few weeks. But if you're interested to find out more about the research of our consortium, then please do keep those dates free in your diary. And I'll put some links in the chat once we get started if you want to find out more about what our consortium does, who we are, and more information about how you can keep up to date with our activities. With that, it's my great pleasure to welcome Professor Matt Keeling, who is a professor at the Mathematics Institute and the School of Life Sciences at the University of Warwick. He is the co-lead of the JUNIPER Consortium, along with Professor Julia Gog at Cambridge. And he sits on numerous different government advisory bodies, including SPI-M and JCVI. So he's going to be speaking today about the work that the Warwick group have been doing on the various different roadmaps. So we're on to roadmap 5, which is the projections for the coming winter of what's going to happen with COVID, and in particular, looking at booster vaccinations and waning immunity. So we're quite lucky within the consortium. Matt's work was recently published on the SAGE website. The report was published on the SAGE website, but we've also had another group who've taken an independent, a slightly different approach to looking at the projections for what's going to happen in winter by looking at trying to estimate the R number and total number of cases. And that work was done by the University of Bristol, led by Ellen Brooks-Pollock and Leon Dannon there. And if you're interested to find out more, I will post links in the chat. But hopefully they will get to present that work at the research meeting in December. So just to say that Matt's work is part of a body of different research groups that have been feeding in advice on what's going to happen over January. So with that, Matt, I will pass over to you.
Thank you very much. So hopefully you can all hear me. I'll just share my screen and then we can get started. Okay, so as Cara said, this is really about roadmap 5. It's been a major effort by various people at the University of Warwick, but I'd also like to do a special thank you to Amy Thomas, who's been sort of helping put us right on some of the basics of the immunology that we start getting wrong. And I think really this roadmap has taken us from the sort of simple models all the way through to sort of more complicated questions of thinking about how boosters and waning and lots of other complexities all sort of start feeding into each other. So big thank you to JUNIPER, which is this Joint University Pandemic Epidemiological Research Consortium that has been funding the work, and also to INI for hosting this talk. Okay, so it's going to be about the roadmap, but this is never a single person's effort. So just to sort of point you in the direction of some people that we've been working with on all this. So there's a very large team at Warwick who've been helping since the beginning of the pandemic. Everything from sort of new models to dealing with some of the complexities of the data. There's the huge team that's part of JUNIPER. These are just the PIs that are listed on the right, but there's also a vast number of postdocs who've been there and sort of have always been able to give their advice. And then there's the team at the Kemry Wellcome Trust in Kenya, who've also been doing very similar models, but for the Kenyan situation. So there's been a lot of back and forth feedback between our group and them. So what you see is merely the tip of the iceberg in terms of people and the sort of support that we've had. So this is actually, so although I've called it Roadmap 5, it's technically the 6th one to date. So there was a 4A and 4B, just to make life really confusing. And in common with all the previous roadmaps, it's thinking about projections of the likely impact of what's going to happen going forwards. 1 to 4 were really about each of the step changes in the government's roadmap to relaxation. This is why these things are called roadmaps. So how we moved out of the very tight lockdowns that we had during sort of January, February, to a situation where we now have very minimal constraints on what people are able to do. All the work has gone through SPI-M and SAGE, and there's also, as well as sort of all the JUNIPER consortium sort of having input, there's also been input from the whole of SPI-M in terms of sort of just polishing, fine-tuning, and sort of getting the right assumptions in there. One of the things that it's worth noting is there's often, or at least a 2-week delay between undertaking the work and the document actually sort of being published. So very often we're 2 weeks behind when these actually go to press. So there's always a bit of a lag in the system, which can end up with people going, why haven't you taken into account this that happened last week? And it's because, well, we've done the work before then. So we're thinking about these 6 roadmaps, but I'm mainly focusing on what we've done in 5. But I want to sort of take you through the chronology of things, because I think it's quite important, because it really does show how the modelling has developed in that time. So roadmap 1 happened in early February. This was sort of when we started thinking about how do we start relaxing the dynamics. We were in a pre-Delta world, so no one had even thought about Delta variants at that time. Vaccines had started, but we had a relatively poor understanding of vaccine efficacy. We still didn't really know the parameters that underlied how well the vaccine was going to work. We didn't understand things like the differences between Alpha and Delta, between Pfizer and AstraZeneca that well. We really didn't have a good estimate of how well the vaccine efficacy would be against death, simply because it's such a rare occurrence. At the time, we did 2 different sets of assumptions about the vaccine. We had a sort of a central set of assumptions, which is shown at the bottom, which we thought were the most plausible, but we also had a cautious set, which was sort of the lower 95 percentiles of where we thought we could be with the vaccine. So yeah, how bad could the vaccine be? We're probably, well, we're certainly at the central assumption, if not better. We also thought about how much transmission there might be once we're relaxed, which was at the time called phase 5. And so we're probably sitting in one of these low, these lower value epidemics where we've had relatively little transmission in phase 5. We haven't switched back to complete pre-pandemic mixing. The steps were rolled out relatively gradually, and we have some quite good vaccine efficacy. So what this basically means is that we were looking at this, but it sort of set the tone for the rest of the roadmaps in a way, in that what this said was that, what we really needed to see was a slower relaxation of controls. So basically we are far better being in the yellowy orange situation than the purple, because that always gives us a better outcome, because we're smoothing that transition from being in lockdown to being sort of complete random pre-pandemic mixing. So as we move through, roadmap 2 was done in late March. At this time, the timetable, or at least the fastest timetable for relaxation, was now set. So that the first roadmap was thinking about what the timetable might look like. We were still really underestimating vaccine efficacy. Our default was thinking, we might have sort of 90% against mortality. We're probably in the high 90s now, probably 97, 98%. So far less mortality in individuals who've been vaccinated, and also sort of better control against hospital admissions as well. So what this was thinking about was how relatively small changes. We started being much more specific about all the uncertainties that were in the model, and really thinking about how quite small changes could make a big difference to the projections that we saw going forwards. There was a large amount of uncertainty just around each outcome, which is shown by the confidence intervals. And we looked at things like, how well, what was the vaccine efficacy? As I said, we hadn't really got a good understanding of that. We're probably at the higher end, so we're on the green line. We also thought about seasonality for the first time, and then also, what happens once we're out of lockdown or any of the control measures? How do people react? As we move forward to May, we'd only really got the alpha variant in, so most things were based around that. But we did have this inkling that other variants of concern were on the horizon, so we started thinking about the implications of new variants, quite often thinking about what would happen if a variant came in that could escape the existing immunity within the population, which gave rise to all sorts of scarily large waves if there was very, very little cross protection with the new variant. Fortunately, the Delta variant has very close cross protection with the Alpha variant, so we're not seeing those sorts of situations. But it sort of set the scale for thinking about new variants coming in. We also thought much more about how to explicitly capture the uncertainty. So we've been having lots of plots with means and confidence intervals. We're now thinking more about spaghetti plots, which I actually think are a better way of visualizing what's happening, but also really characterizing the huge uncertainty through all the different simulations in thinking about total numbers in all the different scenarios. Roadmap 4 was in early June, and this was sort of when the alarm bells started sounding about the recent spread of the Delta variant. I mean, we've gone from thinking about it in one roadmap as there might possibly be some variants coming into, oh, the Delta variant is dominating and has spread dramatically. And this, together with other data, really led to the delay of step 4, largely because of the uncertainties around Delta. We didn't know how fast it was spreading. You can see this main plot here is thinking about the transmission advantage that Delta has over Alpha. We're actually sitting somewhere in the middle, so our estimates were reasonable. But there could be lots of changes depending on how fast it could, how fast Delta could spread. And there were estimates at the time that were putting it as spreading at least, almost twice as fast. So we had to cover a large number of bases in thinking about things going forward. And again, there was also some uncertainty about vaccine escape. So some of the very early data on Delta suggested that vaccine efficacy was much lower. So we'd be in these sort of red bars on this side of low efficacy. But actually, most of the data now suggests that the difference between Alpha and Delta in terms of efficacy is relatively small. The efficacy is not quite as good against the Delta variant, but the differences are within a few percent for most things. The last but one roadmap, so 4B, which came in early July. Well, by then Delta was dominant. We didn't need to think much about which variant we were dealing with. We knew which one it was Delta. There was still some level of uncertainty in the vaccine efficacy parameters, but we were much more driven by good population level data on vaccine efficacy at the time. But what we realized by then was that actually the thing we were terrible at estimating was population behavior. We'd always assumed that we were going to get to each of these step changes in the roadmap. So when pubs open for the first time, or when people are allowed to mix within houses, we assumed that this was going to give us a step change in behavior. We thought, each one would do this. And then when we got to step 4 and there was sort of removal of almost all restrictions, we might go back to sort of pre-COVID levels of mixing. When we look back at the data in retrospect, we realized that this didn't happen. There weren't these abrupt changes in behavior every time policy changed. Yes, as soon as pubs open, people will go into pubs, but it'll take some time before people start getting comfortable with the ideas. And so actually this document focus much more on the scale of the changes that might happen after step 4 and how long it will take to return to pre-pandemic behaviour. So it's something we still don't know. It's something we're still sort of questioning. So we looked at scenarios like this here where we start, there's only a small change when step 4 happens, and there's a gradual decline in precautionary behaviour. So how much sort of people are trying to avoid risky situations, and that could return to pre-pandemic behaviour, which is 0 here at different timescales, or there might be a big drop and then different rates of return. So we considered a whole spectrum of different things. Not surprisingly, our confidence intervals were enormous, simply because we were considering such a big envelope of possible behaviours. But it does mean that we were relatively close. We were relatively close to being able to project forward of what's actually happening. We're probably sitting somewhere around the red lines on a lot of these graphs. So, some sort of slow decay. We're not quite at returning to pre-pandemic mixing now, but we're not that far off in some circumstances. So that was the roadmaps to date. This talk is mainly about roadmap 5, which is early October. So we've now been doing this for about 8 or 9 months, and roadmap 5 was really about what's going to happen into the winter. A lot of it is based around the uncertainty of waning efficacy. So all the previous roadmaps, if you were vaccinated and protected, then that protection lasted for as long as we were actually simulating for. But as we came to roadmap 5, booster programs into the winter, we really did have to start thinking about waning efficacy, and we also have to concern ourselves with the uncertainties in population behaviour. So when I'm going to be talking about roadmap 5 here, I'm going to outline all these different uncertainties, paying particular attention to waning efficacy, boosters, and population behaviour. I'll talk about the immediate dynamics, where I'm thinking sort of the next 6 months or so. I'll then move on to some more recent work, which is thinking about boosters over longer timescales and what we may need to do in a sort of 1 to 2 year time frame. And then finally, a little bit about lessons to the future, which is much, much more speculative, because I really don't think we should be pushing these models that far. But it's interesting to think about what could happen as we move further forwards. So, as I said, one of the main uncertainties on all this is behaviour. So this is the precautionary behaviour that we've seen so far, going back to April last year when we were in lockdown. Lockdowns basically should give us high levels of precautionary behaviour because there's less mixing going on. Times when there's more mixing are giving it low levels. So as we move forward, potential scenarios, we expect these to decline. So what's noticeable here is I've actually got 2 lines on this. So from when we moved into step 2 and things started to really relax more, I split this precautionary behaviour into younger and older individuals. So younger individuals are more predisposed to go out and mix, and older individuals are probably going to be more precautionary. And this is borne out in the data as there's now starting to be more and more separation between these two. And here, younger individuals are under 40 and older individuals are over 60. And those of us in between have some scaling between the two. There's a few noticeable factors in this. The third lockdown seemed to give higher levels of precautionary behaviour than the first lockdown. Unclear quite why this is. It may be because people had sort of adapted to the situation more. There was a lot more mask wearing during January, February time than in the first lockdown. It may be that people were just more aware of what constituted risky behaviour. We also noticed there's a massive decline when the Euros are on, so we really do pick up the impact of the football tournament, followed by the pingdemic. In fact, the pingdemic gives us some of the highest levels of precautionary behaviour that were out there. So if we could replicate what went on then, we have a very good way of controlling future outbreaks. So that's our sort of uncertainty in behaviour. The other uncertainty that comes in is waning. So these are slightly old sets of data, but they're getting changed every week, and keeping up with the changes is quite dramatic. But so what the blue diamonds and red circles show are efficacy estimates from PHE for Pfizer and AstraZeneca as we move time since the second dose. So if we look at the Pfizer data, we see that you're getting about 90% vaccine efficacy or protection against infection in the early days, and then this drops over time so that those who've been vaccinated somewhere around sort of 150 to 200 days ago may now be at only 70% protection. The protection is much higher if we look at hospitalization and deaths. So we're getting very good protection there. AstraZeneca has lower values, but this is in some way biased by the fact that AstraZeneca has been given to an older cohort of individuals. So there's complications in here as to how we actually model it. And the grey lines, grey dots give us a weighted average. And what you can see is we have three curves which approximately fit to the grey lines. There's a lot of uncertainty in these, but what these lines are distinguished by is the value they asymptote to. So the blue line eventually asymptotes to 0. It takes a very long time to get there, but eventually there'll be no protection against infection, but there'll still remain 70% protection against hospitalizations and deaths. The green line asymptotes to 30%, and the red line asymptotes to 50%, and those have correspondingly higher asymptotes in hospital protection and death and protection against death. So we have three different ways of matching to the waning immunity that's in there. So that's our sort of second source of uncertainty. And then the final source of uncertainty is how the boosters work. So we know that the boosters generate very high levels of immunity if you sort of measure it in the lab from an individual. What we really don't know is how long that lasts and what level the sort of efficacy in the field is. So this is our sort of simple model that we've got so far. So we've got susceptible individuals who get vaccinated with first dose, vaccinated with second dose. If they get infected, they move into a recovered class. So that's our sort of simple model of what we were using for sort of the first 4 roadmaps. To that, we've added waning immunity, either as waning efficacy from the vaccine or as waning natural immunity, which is a much slower process. And all of these have levels of infection. So once your vaccine efficacy is sort of waned, you're then more prone to get infected. But again, this hasn't got the booster in. We're just thinking about waning efficacy that we've seen in sort of the previous slide. When we start thinking about boosters, the question is where does the booster vaccine take us? So here in green, the action of a booster is very much like the action of infection. It gives very high levels of immunity that wane very slowly. So we know that you get high immunological measures, but whether this translates into high efficacy is not clear. But we're assuming here that we have very high levels of efficacy that wane slowly over a sort of 5-year-ish time span. The other assumption is that for the majority of states, this takes you back, the booster takes you back as if you've been vaccinated twice. So you're going to get constant repeated waning. So you move, you're susceptible, you move into the vaccinated classes. After 6 months to a year, you get waning efficacy. And then the booster vaccine takes you back as if you've been vaccinated twice. The only exception is if you're in the early stages of waning immunity from having been infected, you go back to the recovered class, which seemed a reasonable thing to do, because otherwise this right arrow here would sort of be taking you from a class with quite good levels of immunity to one with worse levels of immunity. So the booster's always having a positive impact here. So really the way of distinguishing these is the long-lasting booster, as it says, high levels of immunity that last a long time. The waning booster, it's as if you've been sort of back in the double vaccinated class. So we put all these together. So we've got 3 assumptions about the speed of waning, which are the red, green, and blue lines. We've got 2 assumptions about the booster, which are the 2 columns, and then we've got different assumptions about how quickly we return to pre-pandemic mixing. Oops. I thought I'd got some arrows coming. So what we've got at the top is a rapid return to pre-pandemic behaviour. So we're back to normal by sort of early December. And at the bottom, we've got a slow return, which takes us until June. And what we see is that really changes where we see an epidemic wave. So if we're in a very rapid return, we could see a high peak happening relatively soon. Whereas if we're in a slower return, then it pushes things much later, and we wouldn't get an outbreak until sort of May, June time, corresponding to when we sort of fully relax all sort of precautionary measures at the individual level. Because this is driven by individual behaviour rather than being driven by any sort of changes in policy. These later outbreaks are larger simply because there's been more time for waning of the vaccine efficacy to happen in all the population groups. But what we notice is that the longer lasting booster, because it gives long lasting protection to the older individuals who are getting the booster at present, we see that the outbreaks are much smaller. Even when we have the sort of the most pessimistic scenario, which is this blue dashed line. So this is when waning takes you all the way down to no protection against infection. We still see relatively small. We're still seeing large numbers of hospitalizations, but we're not seeing anywhere near the peaks that we can see if we have repeated waning of immunity. And if we're fortunate and we're in the red line where we still get quite a lot of protection against infection, then the outbreaks are even smaller. So these were the projections that went into the roadmap, but they say a week's a long time in politics, but unfortunately 2 weeks is a long time in epidemiology. So as we move forward, so we've got 2 weeks, we've got a bit more data. There's been some very slight improvements to the fitting. We've also got a much better understanding of what was happening in the Southwest. So there's been a large number of things that have come together, which really change the picture of now having slightly smaller outbreaks as we go forward. We've also got a better idea of what the booster uptake is and what the uptake is going to be of the vaccine in children, which is also sort of in here. And the level of precautionary behaviour we've seen over the past few days, for the past few weeks, has changed. So there's a large number of changes that have all come together to change what the predictions are. So what you need to remember with all of these is they are only projections based on a set of assumptions and based on the most recent set of data. And as that data changes and the underlying parameters change to accommodate that, then we can see different projections over the same timescale. So qualitatively the same type of pattern, but quantitatively there are differences. So just as a sort of word of warning and a final sort of type of uncertainty in all this is seasonality. So the Warwick model has always assumed 10% seasonality. So that means that the difference between February, when transmission is at its highest, and August, when transmission is lowest, is 10%. So we have a sort of 10% amount of variability in that. Other groups have done it slightly differently and come out with sort of 20%. Really, no one knows. It's almost impossible to disentangle what the changes are due to climate and what the changes are due to mixing. And therefore, if you're thinking about mixing, then you also have to take into account all the rules and regulations that are in place. So we start to think about what would happen if we changed seasonality and we also sort of added in Christmas to this. So firstly, the impact. So the left-hand column has got fast relaxation. So everything's back to pre-COVID mixing by early December. So Christmas doesn't really have an impact because it's already sort of in the system because we're back to pre-COVID levels by then. These slower relaxation models are assuming that things take until June next year to return to pre-COVID levels. So Christmas can have a bigger impact here. And we're assuming that during Christmas, everyone mixes as normal. So we can see quite a dramatic jump due to Christmas mixing. And it's one of the things that's sort of concerning us all at the moment. But the behaviour that we get is also quite non-linear. So in general, as we add in more seasonality and as we go down the page, we see that given there's more transmission in the winter, we'd expect to see larger outbreaks. So you can see this really clearly in the blue line, where we've gone from something that peaks at about 1,500 hospital admissions per day to something that peaks at over 2,000. But we can have it where you see the reverse, that the greater transmission in the winter that's happening down here has depleted some of the susceptibles, and so it suppresses the later spring summer wave. So depending on the type of outbreak we have and how early that occurs can actually change how seasonality impacts what we see going forward. So, and then finally, this is the sort of the synopsis of all the different behaviours that we considered in the roadmap. So on the left here, we're looking at different changes in precautionary behaviour and how long it takes to get back to sort of pre-pandemic levels with 10% seasonality. These other graphs are looking at different levels of seasonality and different times to return to pre-pandemic mixing, and these have all got Christmas in, which is why they've got a little star on the percentages. But what we can see is that there's a huge range of possible behaviours going forwards, partly dependent on whether or not the boosters act as sort of something that gives long-lasting immunity, or whether we see repeated waning, which is whether we're in a solid bar or whether we're in a hashed bar, but also depending on what we think is going to happen in the long term with waning vaccine efficacy. So all of these are thinking about what happens in sort of the next 8 months or so. And although some of these could generate very large epidemics, I mean, these are all without any additional mitigating controls. So this is assuming that we would do boosters, we'd roll them out to the over 50s, and then we'd stop and we'd just let the epidemic take its course, no matter what's actually seen. But in reality, if we start seeing any of these larger outbreaks, then we're going to have to start thinking about introducing different controls over longer timescales. And that's really what I want to talk about in the last little part of this talk, is thinking about different types of control within the system, and really thinking about different types of boosters. So I'm now moving from projections that were over 6 to 8 months to thinking about projections over about 2 years. So we're now going forward to October 2023, and thinking about the range of different epidemic behaviours and the types of different booster programs that could be deployed. This is all plotted on a log scale. I'll show you a linear scale later. The log scale is just easier to be able to see what's happening. We're again separating out long-lasting boosters in the left-hand column from waning boosters in the right-hand column. The top set of bars are thinking about annual boosters. So it's clear, certainly if we've got boosters that wane fairly rapidly, that we might need to think about additional control measures every year. So what we've got here is, I'll take you through them in order. So the blue line is the counterfactual of not having any boosters at all. If we don't have boosters, we expect to see lots of waning over the next few months, and we would have a very large outbreak characterized by lots and lots of hospital admissions, especially in the elderly individuals. The dark orange line is boosters to the over 50, so that's the current situation. But we're also putting in secondary boosters a year later. So next September, everyone over 50 will be offered a booster. We're assuming 90% uptake of boosters in the over 50s to those who've had the second dose, but only 70% next year. So there's the idea that by next year, people will be less concerned about it. So We've also tried extending those boosters out to younger age groups. So what if we did, instead of over 50s, over 40s, over 30s, or over 20s, assuming that these would happen sequentially in age. If we have long-lasting boosters, these expanding it out to more age groups has a really big effect, dramatically knocking down the level of hospitalizations. Whereas if we're in a situation where there's continual waning, we don't get the same sort of pattern. Extending the boosters out to more individuals pushes the epidemic slightly down the road. It makes things slightly later, but the actual height doesn't dramatically change. So we may then be in a situation of having to think about different types of boosters, which is what's shown in this bottom panel. And I'll really think about what happens with waning boosters here. So again, we've got the blue line, which is no boosters in there as sort of the counterfactual example. We've got annual boosters, again, which is the orange line. So we've got that in both the top and bottom plots. And then we think about what would happen if we add in additional vaccination to try and control. So the yellow line is annual vaccination of the over 50s, plus an extra 6-month booster that kicks in sort of May, June time next year, or early May, to really sort of knock the forthcoming wave on its head. We've also got a single once only dose, so we only do one lot of boosters, and we don't think about giving another booster in September next year. So that would be this pink line, which, as you can see, keeps very, very high levels of hospitalization. And then the blue dashed line is a biannual program where you'd be vaccinating the over 50s both in September and then again in sort of April, May time each year. So there's sort of 6 months between the booster doses, in the same way as we've got 6 months between the second dose and the booster this time around. Oh, and what this tells us, looking at these graphs, is that if we've got long-lasting boosters, so if we think the action of boosters is going to be similar to what you see with infection and it's going to give protection over a long time scale, then maybe vaccinating the over 50s seems sufficient. We're able to get relatively good control of hospital admissions for a very long time with annual boosters of the over 50s. But if we're in a situation where boosters are waning as fast as we've seen the vaccine wane, then we may need additional campaigns to keep the pressure on the health services lower. So that's all on the log scale, just to show you what that looks like on the linear scale. You can really see how without boosters, we could be in a situation where we got very, very large numbers of cases, at least comparable to what was seen in January, February this year. The booster campaigns do work well to suppress that, but depending on whether we're in this long-lasting or rapid waning scenario, really depends on what we're going to have to do next. One way of looking at these different scenarios is to pull out how many hospitalizations we prevent per booster dose. And what we see is, if we're thinking about long-lasting boosters, then really a single booster dose, so just boosting this year to the over 50s, is highly effective, as we're highly effective at sort of controlling the amount of hospitalizations we get. And then as we move down and think of extending this out, so boosting the over 50s annually or the over 40s annually, we're getting less and less sort of advantage per dose of booster. But if we're thinking about waning immunity, then we certainly need to be thinking about vaccinating annually. And it might be that biannually, or put in an extra 6 months booster in, is important. What I ought to stress is that these results that we're showing here and the ones previously are an average over the 3 different waning assumptions. So we can separate it out for all the different waning assumptions, but then you end up with 6 sets of graphs for everything, and it just gets a bit too much to sort of deal with. So what this suggests is that the over 50s vaccination booster program looks good, certainly for the long-lasting situation, but we need to think about certainly annual boosters if we're in the waning scenario. So as the final part, I want to do a real look into the future, and this is much more speculative, but just thinking about what hospitalizations would look like if we extended this model not to sort of 2 years, but out to sort of 30 or 40 years timescale. So what we see then is if we're in this situation with sort of long-lasting boosters, and we for the sake of argument, I've just done, let's do annual boosters to the over 50s, then depending on how long your boosters last, and depending on what happens after infection, we could be anywhere from seeing outbreaks that are comparable to flu to being much smaller if we have very high levels of long-lasting immunity from boosters and infection. But if you're in the situation where there are no boosters and we've had to swap the scale because the two things are so very different, unless you've got boosters that last an incredibly long time, you are seeing very large, well, infection control that lasts a long time. You are seeing a very large number of hospitalizations moving forward into the future, which suggests that, you know, unless we can get to zero COVID, and I can't see how we can do that under current circumstances, we do need to think about a situation where we're going to be boosting on a fairly regular basis to the most vulnerable individuals in the population. So in conclusion, so the roadmaps that we've been doing over the last 9 to 10 months have been extremely useful, I think, for guiding policy decisions. But it's clear that they're only as good as the assumptions that go into them, and only as good as the data that underpins them. And we've learned a lot in that time. So February, we had very poor understanding of vaccine efficacy, simply because there wasn't enough individuals who'd been vaccinated to give us a good understanding of that. We were also in a situation where we didn't know anything about the Delta variant. So things changed, and things can change very rapidly. What we see looking at roadmap 5, the most recent one, is really only the worst set of assumptions, where there's an early return to pre-pandemic behaviour and where there's high levels of waning vaccine efficacy. Those are the only situations where we seem to be seeing very large winter waves being generated. So we think, and we're all being sort of crossing our fingers and touching wood on this, that it looks as if things should decline over the next few months, and we shouldn't be hitting very large winter waves of COVID. We do expect to see a rise over Christmas, especially if there's additional mixing at that time. So it would be ideal if we could get levels of infection low before we hit the Christmas festivities, simply because we expect there to be lots of people making up for a lack of Christmas last year. So there could be huge amounts of mixing at that time. So we have to be very careful. It looks like good news again on the booster vaccine campaign. It should be effective at suppressing the impact of waning immunity. So if we didn't have the booster campaign, we'd be expecting to see very large waves of infection between now and Christmas. But this all depends on the level of uptake. Data on booster vaccines is very limited at the moment. We don't really know where it's been, what the uptake is looking like. We've been assuming that we'll get high uptake, and that anyone who's prepared to have 2 doses is almost certainly likely to want to have a third. But obviously, our results are highly dependent on that. We also found that depending on how long we expect our boosters to last, so do they look like a second dose of infection or a second dose of vaccine, or do they look like infection, depends on what the dynamics are going to look like over the next year or two, and whether or not we're going to need additional booster campaigns to try and suppress future waves of infection. And then thinking about the very long term, we're probably very likely to need some sort of booster campaigns for the elderly and vulnerable in a similar way to we vaccinate against flu. And hopefully this should mitigate against the worst effects over a very long time scale. Thank you.
Great. Thank you very much, Matt. That was really interesting. I meant to say at the beginning, but I forgot. If anyone does have any questions, please use the Q&A button, or even just type it in the chat. If you type it to the panelists, then we should all see it. So Matt, actually, I had a quick question about the waning immunity. So it seems like how long the boosters will last and how long, how quickly your immunity may wane is quite a critical thing to figure out which of these different scenarios we're in. So what ways are you guys trying to sort of monitor to like get early signals as to how bad or how good the waning may be?
I think most of it comes from talking to the immunologists who are looking at this. So there's evidence that most of the immunological signals have a half-life and do seem to be decaying, even from the hugely high levels of antibody response that we get from boosters. But it's still not completely clear how that translates into what the sort of perceived vaccine efficacy is at the individual level. So I think a lot of it is almost a wait and see game. It's only been in the last 2 to 3 months that we've really started to get good data on waning efficacy from the second dose, and we may be in a similar situation with boosters that we have to rely on population level data rather than sort of lab derived assays, I think. But we'll obviously sort of keep monitoring what's happening.
So I guess like reinfection events will be quite, monitoring reinfection events will be quite critical.
Yeah.
So someone was asking about, I guess, related to all of the work you did looking at the different behavioural, the way in which our behaviour is potentially going to change over the next year. So what do you believe to be the most promising approach to incorporate behavioural dynamics in infectious disease models?
Ooh, that's a good question. I almost want to turn to Ed and ask Ed to answer the question. So I think what this has taught us is there's a lot of uncertainty in it. It's driven by, a lot of external factors that I think are very, very hard to predict. I think, it can be, weather, climate is going to have a big effect. We know that there's sort of more mixing indoors, but what we've seen is things like, the Euros. We'd have all thought, oh yeah, when the football's on, there might be a little bit of increase in mixing, but actually it's an enormous signal. And that had a massive impact. The pingdemic, we still don't really understand the drivers of that. How much of that is people just not getting notified and therefore not testing, and how much of it is actually people doing avoidance behavior because they don't want to get pinged because they've got a holiday to go to next week. But that had a massive impact. And I think those sort of things are very, very hard to predict. You start looking at the data and it's very clear how small things can have quite a large impact. I mean, the Boardmasters Festival, you can see lighting up the whole of the south of England, and yet other ones didn't. And it's not quite clear why you get that. So I think going forward, I think being able to bring in behaviour is going to be hugely important. But I don't think there's easy answers. And I think there's going to be a lot of uncertainty over what actually makes a big difference.
And I guess coming up to Christmas, that's quite a big question, because how people behave is very unknown. So I put a link in the chat for people. There is actually an event on behaviour tomorrow, which is starting tomorrow, that Ed Hill, as which Matt just mentioned there, is organising. So if you are interested in methods for incorporating behaviour into models and how we do this going forward, then I'd suggest checking that event out. So just coming back to that point about behaviour, is kind of one of the challenges that the models at the moment they tend to just use more contact data, and they're mechanistic in the disease dynamics, but they're not mechanistic in the behaviour. So it's quite, when something suddenly happens that you behave out of the ordinary, it's quite difficult to capture that.
I think so. I think it's difficult to know which events will cause people to behave out of the ordinary. So, maybe we could have foreseen the football, but there might be something else that also does this that we just wouldn't have thought of. So I think we can probably start using the data we've got now to get a bit more of an understanding. But I think trying to understand which particular elements drive behavior, I think is going to be the next challenge. And also understanding sort of, what is it that causes people to react in a different way. So there's a slight signal in the data of people being more precautionary as the Delta variant was coming in? And is this because it's on the news every night with people saying, oh, panic, we've got this new variant and we don't know how bad it's going to be? Does that mean that people start limiting their behavior? So maybe we need to have something that brings in media stories and lots of other things, and then you have to classify whether it's a good news story or a bad news story, and that gets, yeah, lots and lots of avenues for future work there, I think.
Thank you. So if no one else has any questions, then I'd just like to thank Matt. I'll give you a virtual round of applause. One day we will actually be physically in a building, hopefully, and we can give each other actual rounds of applause. But thank you very much, Matt. That was really interesting to find out about the sort of whole history of and putting the roadmaps all into perspective. And I guess we'll just wait and see what happens going forwards. So thank you very much, everyone, for joining us. Hopefully we'll see many of you at our event in December, where we're going to be talking more about the various different elements of research that the consortium have been up to. So thank you very much, everyone. Have a lovely rest of the day. Thanks, Matt.
Bye.